Question 7 is to solve problems on projectiles. Here we have a problem, real world problem. An object is launched at an angle theta equals pi by 6 from the horizontal with the initial speed v0 is equal to 98 meter per second. Determine the time of flight and the horizontal range of the projectile. Let's understand this with the help of pictures, over here. This is the basic graphs. I'll tell you what exactly is happening. When you launch an object, it'll go at an angle. Obviously, this is the angle theta, and it's mentioned over here. This angle is given as pi by 6. Now, if you're thinking how much is pi by 6, it's around 30 degrees. Now then, this velocity is also given 98 meter per second. So this is 98 meters per second, and this one over here is pi by 6. So this is what they have told. We need to find the time of flight. That means how long. Now if it's launched like this, it'll eventually go up and then it'll fall down, right? How long will it take to fall down? And the range means how long did it go? So these are the things we need to measure. Whenever you have an angle like an inclination and a velocity, we can resolve it into the vertical and the horizontal components, isn't it? The horizontal component is given over here, it's shown v cos theta, v naught cos theta, that is the velocity, initial velocity, cos theta is the angle, and similarly v naught sine theta. And what about this? Now this is basically the graph of it. That is just for understanding. Now if you understand this part, it's more than enough, but this is also important. Why? Because we will have to use these as the initial conditions. Now after the sketch of the graph, we need to understand the figures, and then we can see what needs to be solved. What exactly needs to be solved here? The time, right? So that will be basically t, and the range is x of t, that is x-axis, right? Horizontal range. Basic things, finding the velocity and the position functions. Now what is the acceleration due to gravity? That is given as y double dash with respect to time. It's always negative 9.8 meter per second square. This is always constant. Now, what happens when you derive this? When you integrate this, what happens when you integrate it? When you integrate it, you will be getting negative 9.8 t. This is just minus 9.8. This is the unit. Ignore that. Plus c, right? Now, what is this c? This is y means it's vertical, x means it's horizontal, right? Now let's find out what is v naught sine theta. That is the vertical component of the velocity. It's 98 sine pi by 6. So you need to put that in the calculator and find it. Here it's 98 times sine pi by 6. Use the fraction pi divided by 6. Now if your calculator is not in the radian mode, you need to change it to radian. Shift mode and 4, and the answer is 49. So the c value here is 49, that is in terms of meter per second. Over here I'll just write y dash is negative 9.8 plus 49. Now the thing is, this is an MCQ problem, but still you have to do the methods. There is no direct way to jump to the solution. You can do shortcuts over here. Once you're thorough with this, you can do it quickly. Now still one more time you need to derive to get the position y. Okay, the position is just y. That would be negative 9.8 t squared by 2 plus 49 t plus c. Now is there anything given about the vertical position or height or anything? Nothing, right? So this is c is 0. So you can ignore that directly, okay? You can substitute and solve and everything, but it'll just take time, and we have done it in the lesson explanations. So now just remember, if nothing is given, just take it as 0. This will be negative 4.9 t squared plus 49 t. So this is the position y. This is all with respect to time. It's y of t. So you can see that will be the answer. And the initial velocity is given over here. You need to solve it up and substitute it back. That's what we got. That is y dash. And then again position, integrated again, you will get this over here equation, negative 4.9 t squared and 49 t. Now altitude is 0. That's the equation, final equation. So that's the position we have got. Now what we can do is we can find the time of flight. But what I would suggest is do the x derivation as well. What is the acceleration first of all? X double dash. It's zero. Nothing is given about the horizontal acceleration. We know only gravity acts downwards. So we take minus 9.8 meter per second square along y double dash. But horizontally, do you push anything? Like, is there any forces, horizontal forces? No, it's not mentioned. So let's just integrate the acceleration of zero. That is integration of zero. What is it? Nothing, that is only plus c. So here integration of 0 would be plus c. It's not a constant. Remember, it's basically only c. And then what is the constant value? C is equal to basically here v naught cosine theta. We know the theta value, and v naught we will find cosine theta now. We know this c value now. Here we have just typed sine, just change this to cosine. Delete this and make it cosine, and the answer is 49 root 3. So the c value over here we got is 49 root 3. Basically this is x dash, the velocity is 49 root 3. That's it, the constant. Now we'll find the position. How do you find? Integrate this again, it will be 49 root 3 times t plus c. Do we have anything regarding the position, horizontal position? No, so we just take this as 0, okay? So it will be 49 root 3 t will be x. That is the horizontal position equation. Now, why do we want to find the time of flight? Because that has been asked, right? But how can you find it? So now, this is the equation, right? Now, what this is, if you graph it up, it goes something like this, the projectile, and it falls down. So when you make this y of t equal to 0, that means height is 0 at this axis. So it should be at the origin, and it will be at the time it will fall down. So ignore, you will get two answers because it's quadratic. Ignore 0, and whatever the other answer is there, that will be your final answer. That is the time, sorry. There are two final answers. That'll be one of the final answer. Let's take our calculators. Here now, finding the time of flight when, I just explained over here, the object hits the ground when the height is 0, isn't it? So we just substitute this as 0. It's quadratic equation now. Mode, phi, and 3. Substitute the coefficient. It's minus 4.9. And then we have 49 t. And there is no constant term. It's 0. So what are the answers? 10 and 0. So over here the answer is already there. So t is 10 and 0. This means this is the initial height. Yeah, because we launch it from 0 and it will fall down after 10 seconds. So the time it takes to land, or the time of flight, is basically 10 seconds. Now we have to do the horizontal acceleration. Over here that is with x. So you need to just integrate this and get the c value. We just now did it, right? This is, we also got 49 root 3, and then over here integrate this to get the position, you get time, multiplied by t. C becomes 0. And what is the landing time? It takes 10 seconds, isn't it? So from here to here, the graph, basically it takes 10 seconds. Now if you multiply this horizontal equation with 10, you come to know what is the distance covered. So just multiply this by 10, you get the horizontal distance. That's it. So multiplied by 10, and whatever is the answer is your final answer. So it takes it covers 848.7 meters. So that is the answer. So that's how we solve this. Now here again it's the same problem, same methods, but only thing is the theta value is changed. So let's do it quickly now because it's the same thing we're doing. So what I would do is, since it's MCQ, no need of all the steps, I'll directly take y double dash, that's acceleration, is minus 9.8, and y dash will be minus 9.8 t plus c. This c is found out with the horizontal, the vertical component, that is this vertical component, that is v naught sine, vertically or vertical always is sine theta, and over here it is v naught cos theta. So let's find it out in the calculator. All you need to do is this speed, see it is, velocity is 98 into sine theta is pi by 3. Your calculator must be in radian mode because it's in pi. The answer is 49 root 3. Let me just write it over here. That is 49 root 3, and even over here it's the same thing. Plus c will be minus 9.8 t plus 49 root 3. Now what I can do is Just quickly change this to cosine and find the cosine value as well. It is just 49. So horizontal, it will be 49 here. Now we need to find the position, that is y. So you need to know acceleration is y double dash. Velocity, when you integrate this, you'll get velocity y dash. And again integrate this, you will get y, that is the position. Now what is this? It'll be 9.8 t squared divided by 2 plus 49 root 3 t plus c. The constant is 0 because there's no altitude given. So let's just solve this. It'll be 4.9 t squared plus 49 root 3. That's done. Now if you want, we can find the time right now. Just equate this to 0 and solve it. By the way, this all is with respect to time, okay? You know, the variable is all time, but I'm just not writing it in detail because this is all MCQ part, just to get the answer here. X double dash of t, basically acceleration, and the horizontal position is 0. There's nothing. So x dash will be integration of this, that's c. But what is c value? It is just 49. Now what will be the position? Sorry, position is x only. This is not there. So it must be only x. That is 49t plus c. And what is c over here? There's nothing given. So it is x is equal to 49t is the answer. Now here, let us equate this to 0 and solve it up. 0 is equal to negative 4.9 t squared plus 49 root 3, right? Let's put in the calculator and find the t values. Here it is mod, phi and 3 quadratic. It's negative 4.9. Then we have 49 root 3. So close the bracket. And over here it's 0 itself because there's, okay, now I have missed one thing. This one over here is t and t. This is the constant value 0, and now the answer is 10 root 3 and 0. So t value is 10 root 3. If they ask you the time of flight, this is the answer. Now what about the horizontal range? Just multiply 49 into 10 root 3. That is what? 490 root 3. 490 root 3 is the answer. Or just put in the calculator and you'll get it. That is 490 or 49 into root 3. It's the same thing. That is 848.7. Now here you can see they have just written as 49 into 10 root 3. That's also fine, but you can solve it as 848, whatever the answer you get in the calculator. Now here we have the same problem again, but it's just that the angle is 30 degrees and speed over here is 40. Then you have to repeat it at the 60 degrees. It's the same thing. But if you're using degrees, remember, don't keep in radian, just change it to degree mode. Please try this by yourselves. It's the same thing what we are doing over here. And now next part over here is from the example 5.5. Venus Williams, one of the greatest, women tennis player, has one of the fastest serves in women tennis. Suppose that she hits a serve from a height of 10 feet at an initial speed of 120 miles per hour. This is mph, miles per hour, and an angle of 7 degrees below the horizontal. So it's going downwards, negative 7 degrees. The serve is in if the ball clears a 3 feet high net, that is 39 feet away, and it hits the ground in front of the service line 60 feet away. Now, and determine whether the serve is in or out. So what happens is whenever you serve in tennis, this is the net which is 39 feet away, right? It must pass. Now, if it touches the net, it will fall in this court and it's a foul. It must pass this, so it must be more than 3 feet. And what happens is it must not go outside the service line. If it falls over here, then no, there is no, this is out. It must fall within this region. See this region, this line is there, right? Anywhere in this region. So we need to see with this particular, speed and this angle, whether the serve will go in or out. So let's try solving it. So over here, let's see in detail, and the next problem we'll solve directly, Write the given from the question. What is given over here? Now this is very important. Everything is in feet here, isn't it? But look at this, 120 miles per hour. This is changed to mph. Now instead of converting all the feet to miles, it's better to convert this miles per hour to feet per second. So the conversion is basically you multiply by 5,280. That is from miles to feet. And why are you dividing this by hour? Because it's from hour to second we have to convert, feet per second. So this is the conversion. But generally in your exam, you will get in feet per second itself. But otherwise, just try to remember 5280 by 3600. Now 3600 is number of seconds in 1 hour. Now the angle over here is 7 degrees, but this is below the horizontal, so it's going downwards, so it's minus 7 degree. And the height over here is also mentioned, it's 10 feet high. That's the initial position. So now let's solve. How do you solve it? Let's do the vertical component, that is y double dash acceleration. Now don't use meter per second. What is it in feet per second? You must remember it is negative 32 feet per second square. That is the acceleration vertically. And now velocity is what? Integration of this, it will be negative 32t plus c. Now how do you find this? I hope you remember this. We just now did it, right? A while ago. Now for the vertical component, it's v naught sine theta. Here, this is there and this is there. Now there is an important thing to remember. Let's take our calculators. Let's substitute it. 176, that is in feet, multiplied by sine minus 7 degrees, right? Is this a correct answer? That is wrong. Why? Because I was having my computer in the radian mode, shift mode. Now change it to degree. This is the correct answer. I hope this is clear. The C value is not 144 something. It's negative 21.44. Why? Because I'm using degrees for theta, right? So I must convert it into degrees. So whatever the theta value inputted is degrees. So here the answer will be negative 21.45 feet per second. Now integrate this and what happens? So now this is what basically the initial that is C value, constant value. Now this is the final answer, but you need to integrate this again to get the position. So over here, let us just integrate it. That's the position. When you integrate velocity, you get position. And over here, when you integrate it, it'll be t squared by 2, that is 32 divided by 2 is 16, minus sign remains. And over here, it will be just a t multiplied and plus c. Do we have initial height over here? Look, they have given. That is 10. So c is what? 10, right over there as 10. So this is basically the vertical position. Let's do the horizontal one. X double dash is always 0. We start with 0, integrated, you get c. Now what is this? It is v naught cosine theta. But make sure you put minus 7 degrees and the calculator is in radian mode. Now solve it up. Here this is the value. So substitute back in over here this x dash of t equation. So you will get over here x dash of t as 174.69. Now integrate this to get the position. When you integrate it, you just multiply it by t. There is no constant value in the horizontal. They have told nothing about horizontal positions. So now there are conditions. At what is this horizontal distance? 39. What must be the height? It must be greater than or equal to 3. And at 60, this must touch, before 60, it must touch the ground. So the conditions I'll write. First, we can take x is equal to 39 and find, once you find that, you will find t over here, right? Use over here 39 and find the t value. Then substitute this t value in that horizontal height equation, y of t, and then check whether it is more than 3 or less than 3. That's the thing. Next thing, what you need to know is, what happens when it touches the ground? What is the height? Y of t will be 0. So we need to solve this equation at y of t is 0 and you'll find time, right? Then substitute the time over here in the horizontal distance and you can find whether it's outside or inside the boundary line. So let us see, these are the two conditions. We can see here, first case, x of t is what? This is the equation which we just now found out, the horizontal position. Substitute x of t of 39 because we saw in the net is 39 feet. So now solve for time, it is 0.223. And then now put this in the vertical position, that is the height. And over here, when you solve that, you will get the answer 4.42 feet. That means it's about 3 feet, right? The net was 3 feet. See the 3 feet high. It's more than that, so it's fine. The ball is high enough to clear the net. That's good. Now what we need to do is whether it lands before the height of distance of 60 feet. Let us check. Now we will consider the y of t as 0 and substitute in this equation over here. Solve for the time. You will get 2 times mod phi 3 One is 0.37 and one more is negative. Time can't be negative, take only the positive value. And now substitute this in the horizontal distance. When you substitute over here 0.37, what is the answer? It is 64.6. That means what? It is away from the service line. It doesn't fall before the service line. If you see the figure in the previous slide, here, when she hits, it'll clear this net, but it'll go outside because this service line is there, right? It'll go outside that. So this is out, the serve is out basically. So you can tell it is by just 4.6 feet, it goes away. Since the serve lands beyond the service line, the serve is out. This is how we solve it. Now this is the detailed way to solve it. Now we have the same problem, only the difference is angle is 6 degrees. I'll solve it now. But here we will directly solve it. I mean, we will not go into more details, but now the thing is you need to know the initial values. I'll just go back to the problem, write the initial values and then continue. Now this is the initial values what we have. Now what we will do is start with acceleration, y double dash. Acceleration is how much? Now don't take it as minus 9.8. It is 32 feet per second square. So that is what I'll take. Now integrate this. You will get y dash, that is the velocity. So it will be minus 32t plus c. Now don't forget, how do we find the c value? C value over here is v naught sine theta. That will be, what is v naught? We have to take the same value, I believe. Okay, again, I'll just go back to the previous, oh no, sorry, over here it's given, yeah. So 176 times sine. Now don't forget it's negative 6 degrees. So let us use the calculator and solve it. All I do is substitute these values as it is. It's in degree mode, and the answer now I got is negative 18.39. So I'll just write it over here. The answer is negative 18 point. I'll write it as 4 because it's 397. So this C value y dash is equal to minus 32t plus, sorry, it's minus now, 18.4. Now what is y, the position? Integrate this. It will be negative 32t squared by 2 minus 18.4 by, sorry, nothing by, it is just multiplied by t plus c. What is the initial height? It's 10, so y will be equal to minus 32 by 2 is 16t squared negative 18.4t plus 10. That's it. That is with the horizontal part, sorry, the vertical part. Y is always vertical. Now horizontal is the x. Y is done. Now this is vertical, this is horizontal. Now what we will do is we will take x double dash. What is it? 0. What is x dash? Directly write c. What is c now? Just change over here in this value from sine to cosine. It is 175.04. That is equal to 175.04. And what is x? That's the position. It will be 175.04 time. Plus c, but c is 0. So this is it directly. Now we need to find whether the serve is above 3 feet or no, right? So here we have x of t, right? Now here you need to know what is the distance of the net. I'll just go back to the previous problem again and check because I forgot that. So that was 39 feet. The net is 39 feet. That is equal to 175.04 t. Take this to the other side. Just divide 170, whatever we have, just divided by 39. 39 divided by answer. Now 0.222 you can just take. I'll just take it as 0.22. So time is basically 0.22. Now what you need to do is you need to substitute this time where over here and solve. So y of 0.22 is equal to, just substitute over here. I won't write it again. Let's do it in calculator directly. I have typed this equation over here. Let's calculate this at 0.22. So the answer is 5.17. Yes, that means it clears, you know. So 5.18 I'll write feet. So it goes above the net. That's fine. Now what about the other part? Will it fall within 60 feet? Because I saw that time it was 39 feet for the net and 60 feet was for the boundary line. Now then what you need to do is basically here solve this at 0. because when y is 0, it'll be a quadratic equation. Solve the time when it touches the ground. So let's just do it. So over here mode 5 and over here option is 3. It's negative 16 minus 18.4 and lastly we have 10. So 10 and let's solve it. It's 0.4 and negative. So we'll just take the positive value of time. We will just take t as 0.4 and substitute it in this equation here. So 175.04 times 0.4, sorry. Whatever the value, if it is exceeding 60, it will not, the serve won't be in, it will be outside. If it is less than this, then if it's less than 60, it will be inside. So here I've typed the values. Here, what is it? It's 70. That means it's away by 10 feet. So here we won't be able to get the serve as well. It is 70 something. So no, the serve will be out itself even in this case for 6 degrees as well. Now then, you can see here. Now over here in this particular problem, they have done all these the same thing, whatever we have done. They have not solved it. They have kept in theta. Why? Because they are finding the smallest and largest angle where the serve will be inside. So at 6 degree we did right. Whatever we just now did, that's correct. And then what, by trial and error, by changing the degree, how much will it be done? For this you need, a graphing calculator, because it's not possible, and such problems won't come since you have MCQs, right? You'll be either asked to find for this angle or this angle, so not to worry about this. Over here they are just finding which is the range of degrees it'll be allowed. So this is the range by using calculator, graphing calculator and computer algorithms. The next problem is the same thing. You're just changing the speed. The same concept is repeated. But now for the same degrees, it's -7, but the speed now is different. We had about 175 or 76, I believe. Now it's reduced. So will it go in or no? You can solve this by yourselves. Same concept. Next concept over here also again is the same problem over here. And see, for different degrees, they have just tried out because they have told trial and error. For different degrees, these are the values. Now, there is another problem. The figure is given, and over here it's about the baseball. A baseball pitcher releases the ball horizontally from a height of 60 feet, and which has an initial speed of how much? 130 feet per second. Find the height of a ball when it reaches the home plate 60 feet away. Hence, determine the time of flight for X equation. Now, 1 minute, I'm just confused. From a height of 60 feet, it's not possible, I think so. This is 6 feet. Why? Because 60 feet means it's 10 people who are 6 feet tall. It's not possible. It's not practically possible. This is an error in the question. It can't be 60 at all. It can be anything like 6 or 5 or something like that. And over here, determine the time of flight from the X equation and then use Y equation to determine the height. They're just telling you the equations, the horizontal and the vertical equations, right? Use this and use that. Now let's quickly solve it. Y double dash is how much? Now since they have given in feet, I will write it as 32 feet per second itself. Second square. Next, Y dash will be what? Minus 32t plus C. Now what is C over here? Is the velocity given? The horizontal velocity is given. See, they have clearly told horizontally. The speed is horizontal. See, they have mentioned even in the figure. So this C is 0 basically. Okay, there's nothing. And Y, that is the position. Y position, Y only is how much? Minus 32t squared by 2 plus C. Now, what is this value? This is the height. It's given as 6, right? So Y is equal to negative 16t squared plus 6. So this is about the vertical part. Vertical. Now horizontal is x double dash. That is equal to 0. What is x dash? We just convert this. This is constant. There's nothing, right? So it'll be a constant. Then what is the constant over here? They have told, see the initial speed. It's at the right side, so it is 130. Okay, it is feet per second. That's the velocity horizontally. And x will be what? Integrate this, will be 130t plus c. But do you have any horizontal distance or anything? No, so it is basically 130t itself. That's it. Now what next? Here we need to find what? The height when the ball reaches the home plate. Okay. So when x is equal to, at x is equal to 60 feet, what is the height? What is y? So first let's find the time and then substitute it over there. So when x is equal to 60, that means 60 is equal to 130t. Cancel this, it'll be 6 by 13 is equal to time. So at y of 6 by 13, what is the value? Over here, just put it in the calculator. Instead of t, put the 6 by 13. So all I have done is over here, minus 16 t squared. T is what? 6 by 13 squared plus 6. What is the answer? It's 438. Let's just find it like this. It's 2.59. So the value will be 2.59 here. So this is what they wanted, right? So find the height. It'll be 2.59 feet from here when it's been thrown. Let's just check the answer. You can see over here, that's the final answer. It's 2.59 feet. That's how we solve this. Now here again the same concept, but what they have done is 80 feet. So the same thing, you just have to repeat it what we did over here, but change the speed to 80 and solve it up. Here's the solved problem, and that is the end of question 6. It's a bit lengthy, but just remember, first do vertical part, y double dash acceleration is always 9.8 or negative 32, both are negative. Horizontal is x, it starts with 0 and then you find the positions. You have to double integrate both the sides and then see what has been asked and solve accordingly.